Hello, I'm Sean Lamp with Danfoss Drives North American Service Department. Today I'm going to go over how to analyze the data captured by NXS and NXP drives when they have a fault.
Please take a moment now to read the safety warnings shown here. Failure to follow these warnings could result in death or serious injury.
In our next example here, we have a service info file from a drive that was sent in. Let's see what the issue here is. So we go down to the fault history, and we can see here we're getting motor over temperature faults. Now normally this probably wouldn't be a fault that we would use a data logger to troubleshoot, but the customer said that the drive had been working in the past fine, and now all of a sudden it's starting to trip on motor over temp, and they can't find anything wrong. So we pulled the service info file from the drive, and looking at the fault history here, we take a look at it. At the output frequency, 58.31, I said we're close to that 60 hertz. Motor current 738 amps, 446 volts. We're at 107% power and 111% torque. DC bus voltage is at 666 volts. Temperature is 73°C, so we're getting pretty warm. Subcode S1, I said that's just a normal motor over temperature trip. It's a calculated motor over temperature trip. So we go up here with the current that we got, 738 amps, and we take a look at the motor data that's put in here. So we're right about by current limit. The motor nameplate is 677. So with 738 amps, I would expect the drive to probably trip on a motor over temperature because you're constantly putting more current to the motor than what the motor is rated for. Down here it's at 714 amps, 722 amps, 693 amps. We're always pushing a little bit more than 100, about 110% torque or so. Our power here is a little bit lower. You can see we're a little bit lower in frequency, but here we're up in frequency, pushing 110% power. So we say, all right, let's trigger the data logger. And what we did for this is that we just triggered the data logger while the drive was running to get just to see what the drive looked like when it was running. So this is a data logger that we had just triggered from the drive. So this is just a force trigger that we triggered, so it's just a drive running along. So let's just take a look and see what's happening with the drive as it's running along here. So we just kind of expand out a section here, and again, kind of looks like a mess. So let's just start to break things down. So first things we want to look at is probably we just want to look at our currents and DC bus. So let's get rid of everything else to begin with. So as we look at our currents and DC bus, I said all of our currents are scaled on the same level. So we're all 3000, 3000, so they're all scaled. If you got some weird scalings, you may have to go down here and type in the scalings, make them all look even. Now DC bus here looks like a sinusoidal waveform. That's our pink waveform here. And that looks like an awful big ripple on the DC bus. So let's figure out what's going on with DC bus. First thing we want to do, because it does auto scale, we want to see what the scalings are. And it's from 560 to 748 volts. So that's a pretty wide range of scale. So that's a pretty high ripple there. So let's take a look and see what that ripple actually is. We'll just pick out one of the peaks here. And at the peak we're looking at, we got about 735 volts DC, which is plenty high. Nothing wrong there, but let's go to the bottom. Let's move it over to the bottom. And there we got about 577 volts DC. So we got pretty close to right around 150, 160 volt ripple, and that's a huge DC bus ripple. We might expect 20 volts or something like that, 20, 30 volts, but nothing in that range because it looks sinusoidal. I say, all right, well, what's going on to make that much of a DC bus ripple? Look at our currents. Our currents are up there. We're pushing right around 100%. We want to bring in the motor current unfiltered. You can see motor current unfiltered kind of looks like a sinusoidal waveform too. And it's going from 810 amps down to about 463, so it is varying quite a bit as it's going out there, but you can see it's kind of opposite of what DC bus does. That as DC bus gets high, your motor current gets low. As DC bus gets low, your motor current gets high. So that's telling us that obviously there's something wrong with the DC bus. So, well, we can figure out that this is a normal 6-pulse drive. If we take a look at the service file, that is a PA power section. 730 amp, 500 volt. So this should be somewhat of a normal 6-pulse drive. So we know the 6-pulse drive, what should our DC bus ripple frequency be? I said with a 6-pulse drive, if it was 60 hertz, 6-pulse, you'd have 360 hertz DC bus ripple. That you take the 60 hertz by 3-phase, gives you 180 hertz. You rectify the other half, gives you 360 hertz. So let's see basically what the frequency is here. So going off of our time scale, we can see this is about minus 656 on the peak here. So let's go to the next peak. Well, we'll go back to this peak. 656 to 666. So about 10 milliseconds that we have in between the peaks here. We'll just check another one, see what that's like. 656 to 646, so pretty consistent that it's about 10 milliseconds. 46 to about 636, somewhere in there, so 10 milliseconds. So if we invert 10 milliseconds, we get about 100 hertz. Now 100 hertz, that's about a 50 hertz single phase. So what we're looking at here, it looks like we got a 50 hertz input, and that 50 hertz input is single phasing. So say, all right, well, why is the drive single phasing? Should it catch that or not? So we go back to the service file and we look at our parameters and we look into the protections right down in here. Stall protection, input phase protection, they have set for no action. So we'd have to ask, why is the input phase protection set for no action? If there's no reason for that, say, all right, let's turn on our input phase protection and see if the drive sees it as single phasing. And in this case, that was true. We turned on the input phase protection, and this drive here immediately faulted out on input phase. That one of the fuses was blowing on the input. So it's somewhat important that these protections are turned on so that they can protect the drive. Because if the drive ran too long in this circumstance, I said fortunately here they were having a problem where it was tripping out on motor over temperature. But this is a huge current draw off of the capacitors, because once you go past the peak right here, where it's on the peak, I said now right in this section, all the way down to there, that's where we're drawing off of the capacitors. So that's a big area that we're drawing off of the capacitors. Once we hit the bottom, we start to come back up. That means we're starting to draw off the line again. So this is a big area that we're drawing through there, so we're going to be heating those capacitors up quite a bit simply by the current draw that we're pulling through those capacitors. That, and we're stressing the rest of the drive out also, that obviously your rectifiers, once you go to a single phase, your current goes up by 1.73 times. That it's more current through there. We're also pushing more current on the output, that it's waving up and down here, that you can see that when DC bus is up about where it should be, we're only putting out about 542 amps on the output. When DC bus is down at the bottom, where it shouldn't be, at that low DC bus, we're now putting out 781 amps. So we're pushing a lot more amperage through the drive than what we should be. So this would be pretty tough on the drive, and will definitely shorten the life of the drive. Your capacitors won't live long this way. That you will overheat them and they will fail in a grandiose fashion.
Thank you for viewing. We hope this information has been helpful. Danfoss Drives can provide additional technical support, parts information or repair services options by contacting us through one of the following methods. For immediate access to customer service or a technical support expert in North America, call 1-888-DANFOSS or 1-888 326-3677, or contact us by using one of the listed email addresses. Additional information is also available on our website at www.danfossdrives.com. For contact information in areas outside of North America, please visit our global website at www.danfoss.com.